Hi everyone, this is Jamal and I am an innovator and visionary leader and I'm gonna present to you a new innovation on green energy field. I got multiple ways to produce electricity. I've classified them in three classes and I got two in class A and three in class B and C. And I got innovation on environment, carbon capture, agriculture and even medicine. Uh, I'm going to introduce you one of my Class C electricity production. This is a new way to produce electricity by utilizing water towers and geographical location height differences from the sea level. So it's a new hydropower solution, and it uses water tower in the higher level ground, and in the end ground it takes a few kilometers, and the end point of the head will be in the lower ground, and the height difference will be utilized. So same basics than the classical hydropower station, but it uses a tower and a long pipelines to utilize the height difference of the geographical locations. And my solution doesn't need dam and doesn't have the same effect on environment. When you're building dam, you will modify the environment and other things. And this is that why this is for the environment better, because it doesn't use fuel and it doesn't need dam. And if there is a dam already built, you can, with a few modification, use the same technique to make the dam much more powerful and to produce more electricity, and the efficiency can be multiplied 100 times, even 1,000 times in some cases. How does it work? Torque principles, like all other power plants, same physics are the same. The calculation of power efficiency, we use hydropower formula like in every hydropower station, and the formula is like that. Get the power by multiplying the density, the water flow acceleration, which is 1g, and falling height, which is the head. In that case, it's the geographical height difference between 2 points from the sea level, and the efficiency lose between 75 to 95, and you get the power. What new in this solution? The new thing is it utilizes geographical location high differences, and that is not used in any other ways. The other classical ways, it use the height difference of the local height difference. So that's why they build the dam and they wait to the water level to get up here, and then they open the valve, then it gets the flow, and the flow will turn the turbine, and you get electricity. No, but mine is different. Mine use a geographical location high differences from the sea level, so in that case we don't need a dam, or we don't need to wait for the water level to rise. So you can just assemble it and use it, and the only thing that consumes time is the pipeline, building the pipeline. And when you got the pipeline, it's like a highway. You can connect them, and you can get more power by building more towers and connect them in one same power line, or there's a lot of modification you can use. For example, I used an Asjärvi, which is a lake in Tampere in Finland, and the lake is located at 100 meters above the sea level, and we got a water body, big lake, and that lake is 100 meters above the sea level. Uh, we build a if we build a water tower, which is 20 meters height, 30-meter height, we get a difference from the endpoint. And if the endpoint is the endpoint height is 10 meters above the sea level, and we got 120-meter level above this 100, and minus that, the difference will be 110. And in that case, in my example, it's a Tamnisto Vanta, and it's about 200 kilometers away from each other. It's a long distance. There is examples which the distance is much closer, and the distance is it's much closer to each other. But this is just one example. So by using the formula we talked about, the hydropower formula, and we times all the elements together, and in that case we use 1 cubic meter seconds, the pump of 1 meter, which rated is 1 cubic meter seconds, with this kind of pump to pump the water to 20 meters elevation. Okay, so we got water on which got the head of 110 meters. So by using the formula we got power rate of 780 kilowatts, and that means if we use that power in 1 hour, we get 780 kilowatts hour. But just one thing we have to consider is that we are using electricity to pump the water to 20 meters. So we get a power lose because we are using electricity also, not just gaining electricity like the classical ways in water dam. So by consider that if we use this same kind of formula, we got 225 kilowatts and we get that like the 20 meters, same flow. The difference 20 meters because the water tower is 20 meters. So we got the difference of 555 kilowatt of power. It's a kilowatt of power. We calculate by if you calculate by the pump engine size. For example, if the pump engine is 30 kilowatt rated, then we get much more power. But we assume the worst case scenario to make sure that the project is worth to build, and we can see that it's worth to build because every kilowatt hour we use for to pump water to that water tower, we get 3.5 times, almost 3.5 times in that example, more power. So if you use 1 megawatt to pump water to the water tower, and we get a lot more water flow, then we got in the end point 3.5 times more electricity than what we used. And if we use 1 gigawatt engines to pump more water, so we got more water flow, we got basically 3.5 more water in the endpoint. But in that case, we need to build a big pipelines, and that's the other thing. Maybe it's we have to make a calculation on that, like research, which is what the good size for the for the pipeline and the good size for the pumps and all that things. But it's not our problem now because I'm just presenting the the principle of my of that way to produce electricity, and I've named it a geohydro power station because it go geographical power locations and differences. So geohydro, I name it a geohydro power station. In that example, if we use it for 1 year and the power is 555, so 1 year got 8760 hours. We times that, we got that much kilowatt hours, almost 5 million kilowatt hours in a year, and which in one cubic meter second. That's just 1 cubic meter seconds. So it's about half million euros if the electricity price is 10 cents. And if we got water flow of 100 cubic meter seconds, then it is 50 million a year that the power station will get 50 million euros a year. So it's a lot of kilowatts, lot of megawatts. And if we use 10 towers and each have a water flow of 100 cubic meter a second, we need big pumps, or we need multiple pumps to get that flow rate. We have a production of electricity that is worth 500 million in every year. And in this power station, it's a non-stop. It's not dependent in the solar in the sun, not dependent on the weather, not dependent on the wind. It's non-stop. Like every hour in the year, we can produce. As long we got water in Nasirvi and Nasirvi or any other body, water body, got a lot of water, and in Finland we thousands and thousands of lakes in here. So that's not a problem, and it's green, like it's totally green, no fuel used, no nothing expensive, just this water pipelines. And that's why I've classified that for C class, because of that. That's not big deal, but because oil pipelines, gas pipelines, they have like thousands of kilometers built in the earth and down in the sea, and like it has so much more potential than this, because in the end the water is free, not like oil or gas. You have to pay for that. You build the pipeline and you have to pay for that gas, and when you use it, you will consume will produce carbon emissions and other toxins, and you need oil to for the engine, and you need fuel to the engine, and a lot of money going into waste. In that case, that is better and more efficient and efficient and better for the environment, better for the price, better for the electricity, and that's just my lower class. It's that my lowest of my lower class. That why I'm presenting in public, because just to let you know about me, and I can tell you the class A, it's considered impossible in the scientific community. But when I present for you the solution, it will not be considered impossible, because it will make sense, like this one. Have anybody built this kind? No, they use this classical, and they wait like in the Ethiopia like now, and Egypt is going to almost showing that they will bomb the dam if they did, and problems about this, and they wait that first phase to fill the dam, and take the second phase, and the dam cost milliards to build and decades to build, or the oil Kyoto, which has been 3 decades to build, and it use uranium, and it's have dangers and hazardous materials we use, all that thing. So anybody can come, anybody can try to comment. If you want to debate, I'm ready for debate. Yeah, and I'm ready to help the humankind. I can take humankind to next level. This is civilization to next level with this free energy, and that is just my lower class. I got energy, unlimited, and almost unlimited energy, and we can go after this oil and energy area, and we can focus on other things. And I can tell you, I've been thinking about other things since this energy has been the energy problem is taken away. So I've been thinking that if that energy is the energy problem is away, what else we can do? And there is so many things we can do. We think that we are so advanced and things like that, but that is not true. We are not so advanced as we think we are. Thank you. If you care about the environment, about the people, about the people who are working in the mines, about the climate change, share this video, comment on it, and if you know somebody who can make a decisions to start a project like that, I can help. I can help the environment and the climate, and I got other innovations, not only in the energy. I got in other things will make huge difference for humans, and will make everybody lives much better and much easier. Thank you for watching, and subscribe, share, and let people know about me. Thank you.